Okay, this is Learning Module 5 for Python. And what we're going to be talking about in this video is using Boolean logic to basically control the flow of execution through an application. And we use Boolean logic encapsulated as conditions, and the control structures that we use in Python are called if statements. So that's what we're going to be talking about here in Learning Module 5. We're going to develop an understanding of Boolean logic. We're going to develop an understanding of using logic to solve problems. And then the last one is using Python to actually do this. So, all right, let's move right into it. So Boolean logic, what we're dealing with here is an evaluation of some condition that will result in either true or false. There can only be one answer, and the answer has to be selected from two possible answers, the two possible answers being true or false. And so anytime you have a Boolean condition, that means the result is either true or the result is either false. So for example, you could have a robot that is basically a robot gets started, and then you're asking, the computer is basically asking a question, did the robot hit the wall? If the robot hit the wall, it would be true. If the robot did not hit the wall, it would be false. Okay, so how we might use this type of logic in the control of our program is the robot's going to start. If it hits the wall, it's going to move backwards. So you can see how the flow of control during execution can change. So it starts here, it flows down, and at the diamond shape, a decision is made. The Boolean logic is evaluated to either true or false. And so you take one of two branches. If it's true, you move to the right. If it's false, you move to the left. So based on the condition, the Boolean condition, did the robot hit the wall? If it did hit the wall, the robot's going to move backwards. It's going to go down the right branch. If the robot did not hit the wall, it's going to go down the left branch. It's going to move forward. And then flow of control will then join, and then we'll go robot stop. So one of two things are going to happen here when the robot starts. It's going to make a decision using Boolean logic that will result in either true or false. So we're asking a question, robot, did you hit the wall? If the answer is false, it's going to move forward, and then it's going to stop. Or another scenario is the robot's going to start. The question is going to be asked, did the robot hit the wall? If the answer is true, then the robot's going to move backwards, and then the robot's going to stop. So this is the two main points here is that Boolean logic will evaluate as either true or false. It has to evaluate to either one of those. And we're going to use that result to alter the flow of execution through our program. Okay, so that's the whole point of it. So it's very powerful that now we're able to ask the computer yes/no questions. And so instead of the computer just doing a whole bunch of batch processing, meaning step 1, step 2, step 3, step 4, step 5, now, and then repeat maybe, now we're able to use Boolean logic to say step 1, step 2, evaluate a condition. And based on that result, you're either going to do step 3 or step 4. Okay, so now we can take branches in our code. Okay, so we might be saying things if the player ran into the wall. If it did, you might actually play a sound like a crashing sound. If not, then maybe your player keeps running. You see this in video games all the time. Or if a missile hits an object, if the answer is true, then you play this explosion and you also present a graphic on the screen. If the answer is no, then maybe the missile keeps flying. Okay. So these types of questions that we are asking the computer, this is what we call our conditions. Okay. And conditions become evaluated or are evaluated as either true or false. Okay. Now, Boolean logic, we've seen mathematical operators before. Okay, so we've seen things like this. 1 plus 4 equals 5. 4 divided by 2 equals 2. Marcus plus Fisher, so two strings added together. Again, that's string concatenation. That would result in one string that is simply Marcus Fisher. Now we're going to start seeing 3 less than 4 Okay, it's like, what? Wait a second, what is that? Well, this is a mathematical expression, and it's a logical condition. The answer is going to evaluate as either true or false. So now we've got to start looking at, in addition to our mathematical operators, we're going to have what you call relational operators. So remember, now we're starting to branch away from, well, I mean, you're always going to have mathematical operators, the plus, the division, multiplication, all that. But now we've got relational operators. Let's look at the next page. Our relational operators are this less than sign right here, greater than sign, the two equal signs. This is two equals. Okay, there's not a space between them. They are two equal signs back to back. And that is an evaluation of whether or not two values are equal to each other. So in the Python interpreter right here, I was to say 4 equals and use two equal signs. Sorry, no space in between. Then it's going to come back and tell you that yes, 4 does equal 4. So the two equal signs is a relational operator which is evaluating equal to, equality, okay, versus assignment, which is a single equal sign. You are assigning the value 4 into the variable x. Okay, so I've just assigned the value 4 in the variable x. Okay, so now I can do a conditional evaluation. Is x equal to 4? And it should return with true. If I was to say something x equal to 5, it should come back as false. Remember, a single equal sign is an assignment. It takes a value and assigns it to a variable. A double equal sign is a relational operator that actually evaluates whether or not an object is equal to another object. The less than sign evaluates whether or not something is less than. So you can say, is 3 less than 4? 4 less than 100? Things like that. A less than B. Sorry, that's a character. It's not an integer. Okay? Well, it's not a variable. The interpreter is trying to understand, look at this as what is the value of variable A? We haven't defined it. So if I said A equals 3, B equals 5, and then if I said A less than B, then I could say true. Or the computer would evaluate that as being true. Okay. So then we have less than or equal to, greater than or equal to, and then are not equal to. So these are just our relational operators. Make sure you can understand, like 53 is greater than 13. The answer is true. It is. 13 less than 14. That's true. 20 equal to 20. That's true. So you can actually try these out on paper, make sure you understand these relational operators, and then you can actually type them in the interpreter here and check your work. All right, so this is a game. We typically run this game in class. It's not something we're going to do online in a video, of course, so we're going to actually skip these portions here. That's a game we play to actually get the students a little bit more familiar with Boolean logic, and we do it in person. So, all right, so whenever we want the program, our program is executing, so it's executing one line, another statement, another statement, another statement. When we want our program to take a different branch through the code, okay, we want to change the control. So we basically want to control the flow of execution. We want to change it. Then we basically have to use our relational operators. And then in addition to that, we have the words and or, okay? So we can write logical expressions by using a combination of less than, greater than, less than or equal to, as well as the words and or. Now, for when you're using the words and, so there's and there's the word or. If you're going to use that, you could say 3 less than 4. So that's true. Well, let's do this. 4 less than 3. That's going to evaluate to false. Or 5 greater than 4. What you're doing is you are testing two conditions here. This is one logical expression, though. this logical expression is composed of two conditions. It's going to test is 4 less than 3. Okay, that's false. And it's also going to test is 5 greater than 4. That's true. So you're going to have a false and true here. The the OR operator is going to combine the two. And if it's OR, then just one of the two conditions have to evaluate as being true. So you can say, if this is false, well, then the whole expression is going to be false unless the other expression is true. So we have false or true, that evaluates to true. So in our truth table, anytime you have two false, and if it's an OR, then it evaluates to false. If one of the expressions, if one of the conditions is true with an OR combination, then it evaluates to true. So we'll dive into those in a second. A little bit more examples to clarify that a little bit. But right now, what the main point we want to get across right now is, for us to control the flow of execution, it's going to be a combination of like less than, all of our relational operators, as well as the words and or. Okay. So here's an example. You might have a player, and that player has certain coordinates on the screen that the player moves around. And so you're going to actually test whether or not the player is in certain positions in the game. Okay, so you might say something like this. Here's Mario. He's running across the screen. My screen is actually 640 pixels wide. The current position of Mario is in the X direction. He's at 20, and in the Y direction, he's at 10. So he's over 20 and down 10. And if we move him across the screen by increasing the X dimension, we eventually are going to get to the far right of the screen. Well, we don't want Mario to run off the screen. So if we do want to stop or keep him from running off the screen, then we might write a Boolean condition that says basically, is Mario's X position greater than 640? So it's something we might keep asking the computer and say, hey, is Mario's position greater than 640? No, we'll let Mario keep running in the horizontal direction. Is Mario's position greater than 640? If it becomes yes, then we might want to stop Mario from running, and so that the user can no longer keep Mario running. So we don't want Mario to run off the screen, basically. So it's these where we're writing these conditionals to basically change the flow of control in our program. Okay. Or we might use a conjunction where we say, is Mario's X position greater than 640, or his Y position greater than whatever it might be, 480. If either one of those true, then we want to stop Mario from continuing to move forward or keep running or something. Okay. So we might say, is such and such, is the sky blue and the grass green? Yes, let's go outside. Is the sky dark blue and the grass mud? Then don't go outside. I don't know. My point is, we're going to be combining these conditionals in order to affect the flow of control in our program. Okay? Okay, well, let's see what this looks like. Let's take this out for a spin using Python and just see how do we write these conditionals and ask the computer questions in Python? Well, we do that with the word if. Okay, so it's very similar down here at the bottom right here, if. So we write the keyword as if, and in parentheticals here, that's our condition. Okay, so let's move over here. So the keyword is if. So this is a little program right here. I'm creating a variable, and I'm calling that variable age. So we've done variable assignment. We assigned the value 13 into the variable age. Now here's what's new. This is my if statement. The keyword is if. I use my parentheses. You actually don't have to in Python, but if you jump around in languages a lot, then there's a few points that to maintain consistency. So you'll always see me using parentheticals because I jump from C, C++, Java, and Python all the time. So I try to keep some similarity to keep me sane. But anyways, you don't have to have the parentheses in Python. Anyways, I use parentheses. But anyways, keyword is if. I always use a parenthesis. And then whatever you put inside the parenthesis, that's the condition. That's what you're asking the computer to evaluate is either, remember, this is a binary answer, which means there can only be one of two answers. The result of a Boolean condition has to be either true or false. And so you put your condition here in these parentheses, and you're saying if this variable, the value that's being stored in this variable called age, if it's greater than 20, I want you to do something. If it's not, I want you to do something else. So here's our structure and our syntax. The if keyword, then my condition, and then a colon, not a semicolon, a colon, 2 dots. And then when you drop down a line, almost all editors are going to do this for you, but when you drop down a line, then you want to index, you want to tab over because you want to be indented. What you're doing here is you're saying this block of code. In other languages, we want to show where code belongs with each other. It's grouped together. We call it a block of code. In some languages, you use curly braces to show that certain code belongs together. Here I use a parentheses right here to show that this condition belongs together. Okay, it's something I do logically. But in Python, if you want to show that code belongs or is grouped with each other, then you keep it indented all in the same column. So for example, I've got this program already typed up. Let me just show this here. Let me just get out of here. I'll just create some white space so you don't get confused. Okay, so it's almost identical. My first program statement is I want to print something to the screen. I want to print program is starting. Then I'm going to create a variable called age, and I'm going to assign the value 13 to that variable. Then I'm going to use an if structure. The keyword is if. I'm testing, is this variable here, is it greater than 20? Then I'm going to use a colon, and then I'm going to drop down. Now you see in my development, I'm just using the idle development environment, I'm already tabbed over, so I can say print hello, print goodbye, whatever. You see these lines, how they're all lined up? They're all indented the same number of spaces over. That's how you tell in Python, that's how you indicate in Python this is a block of code. And so these 3 lines, they're all indented the same. That means they're all a block of code. They belong to the same block of code. They are similar, and they belong in the same block of code. They will all be executed together if this condition is true. If the value of the variable age is greater than 20, then the flow of control will execute all the lines that are within scope of this if statement that belong to this block of code. If you notice, this else statement is not indented. That means this else statement does not belong to these 3 lines of code. So if this condition is true, these 3 lines will execute. If this condition is false, then the else block is going to execute, which means this line of code is going to execute. If you notice, this print statement right here is not indented. That means it does not belong with that line of code. So you should see, when you look at this code right now, you can see how some things are indented, some things aren't. These 3 lines of code will execute if this condition is true. This line of code here will execute if this condition is false. So the else statement is the indicator of what is supposed to execute if this condition is false. Okay, so let's look at this. Age is assigned the value 13. We're testing, is the age greater than 20? So it's not in my mind. So I expect for this line of code to be executed. So what do I expect to happen? I expect this line of code to execute. I expect this variable to execute. Well, basically this value be assigned to this variable. I expect this condition to be evaluated. It evaluates to false. That means flow of execution will drop down to the else. This line of code will execute, and then this line of code will execute to terminate. So I'm going to save it, and I'm going to run it. All right, so program is starting. That's what happens right here. Then it says you are not old. Okay, so the else portion ran just as I expected, and then program is ending, this last one. So let's change this up. Let's change this variable here, age, to 21. Now I'm going to assign the value 21 to the variable age. So what do I expect to happen? I'm going to pause a second, and I'll let you think about it. Okay, so I paused. You'll have to pause it too if you want time to think about it. First line of code is going to execute because there's nothing keeping it from executing. So as soon as you run this program, it's going to execute. And it's going to assign the value 21 into this variable age. This condition is going to be evaluated. Is age greater than 21? Yes, it is. So true. That means these three lines of code will execute. This else portion is going to get skipped because this condition was true, and then it will fall down into normal flow of execution and print this. So we should see 1, 4, 5 lines of code printed is what I am expecting. And when I run, I got program is starting. Hello, you are old, goodbye, and program is ending. So it behaved, the program behaved as I expected. Okay. Now, by the way, you should always, when you execute your code, you should always be thinking, what am I expecting my program to do? It's kind of like an exploratory test, if you will. It's you're setting expectations so that when you run it, you'll be able to see actually which parts of it is failing and whatever. All right, so the point up to this is we're using, here's our Boolean condition. We have a variable that we're testing. We're using a relational operator greater than sign. And we're trying to control the flow of execution. So if I was to say, for example, I'm going to set the variable age to 20. Okay, here's a test for you, test question. What is going to execute now that I've assigned the value 20 to the variable age? Go ahead and pause and think about it. And then when you're done thinking about it, come back. All right, so hopefully you've given it some time to think about it. Age is 20, so just like normal, this is going to execute. 20 is going to get assigned the variable age. This condition is going to get evaluated. Pause right there. This variable, age, which is the value 20, the question is 20 greater than 20? The answer is false. It's equal to 20. It is not greater than 20. And so that means this condition will evaluate to false. So that means flow of execution will come down to the else, and it's going to print this and then print that. So I will save it, and I will run this module, and it'll say you are not old. Now, if I change my relational operator to greater than or equal to, then it will evaluate to true. Okay. Make sure you see that. Make sure you understand that. Because this relational operator just says, is it greater than or equal to? Okay. And now it's just testing, is age greater than 20? That means it's false. All right. So we got our keyword if. Our Boolean statement goes in the condition. The colon terminates it. And then we indent our lines of code under the if or under the else, depending on what we want the code to do if it evaluates the true or false. Okay. So I've got some more slides in here trying to show you this concept of blocks of code. So here's my if statement. My if statement all the way down to my print statement. This entire, all of these lines of code right here, if all the way down to print, belong to the outer block. They are all indented the same. The if is indented and it is aligned with the else, is aligned with the print. So that means they all belong to this outer block. This print statement, however, belongs to the inner block. It belongs to the if statement. And then this print statement belongs to another inner block, and it belongs to the else statement. It's very important that you see the scope, this indentation that establishes the scope as well as the blocks of code that should be belong together and execute together for that matter. Okay. So we block statements together to indicate they were to be executed together. If you're an if statement, then that means if the condition evaluates to true, then this block of code here gets executed. If this condition evaluates to false, then the else portion of the code gets executed. You don't always have to have an else statement, by the way, in your code. You can get away with not having that. So I could have something like, I don't want to, let's just take this out. So I could say if age is equal to, let's say, 50, then, whoops, my colon, print happy birthday, whatever, I'm just being silly. Which means it's going to test the variable age. It's the condition is the variable's value equal to the integer 50? If it is, then I want you to print that. If it's not, meaning it's false, well, I don't want you to do anything. Just go, keep. So then all of a sudden it's just going to fall out down to here. So just because I added these lines of code, let's run this. Just because I've added these lines of code, it's actually not going to do anything different. So I didn't have any false portion. I didn't have an else portion of my if statement. Okay. All right. So make sure you understand, you're comfortable with these blocks of code as well as knowing which portions of the code executes when something is true or when something is false. Okay, so now I'm just going to move ahead here. I want to make sure we're comfortable with the spaces. So make sure you look at this and you can see. So here's my condition. Here's my if statement and my condition. My colon, that means what blocks of code belong together. I've got 4 spaces. This rectangle, gray rectangle, represents a space. So 5 spaces over, I've got a print statement. So that belongs to, well, wait a second, this one though has too many. So here, this is going to be an error because the Python, remember, it's the spacing that represents whether or not, or indicates whether or not lines of code should be blocked together. And right here, I've actually pushed this one out or indented this line of code out too far. So that's actually a syntax error. So you got to make sure you have your spacing correct. Your interpreter, your development environment, your editor, should take care of the spacing for you. As you notice here, as I hit enter, my next line of code is already indented for me. Okay. To actually get out of this if statement, I actually have to hit the backspace and come down. Now I'm back to normal indenting. Okay. So it's important you pay attention to that indentations. All right. So let's just summarize on this. We have our relational operators. We've got the double equal sign, which means equal to. Here's an example. Not equal to, greater than, less than, greater than or equal to, less than or equal to. Okay. All right, now we can make things a little bit more complicated, of course, as we always do in programming, right? So where we are is we've left the state of being able to, it's like transistors. Now the computer can actually have some intelligence. It can make some decisions for us. Well, you can also nest if statements. You could, it's probably not the best practice, but you should get familiar with it because some programmers do this. And so if you're reading other people's code, then you've got to be able to follow along. But given these others, especially the LF structures that we have, you don't have to actually nest things anymore. But anyways, you've seen nesting means we're actually putting if statements inside of other if statements, and then if statements inside of that if statement, so we can nest them. It's kind of hierarchical. So here's my if statement here, my outer if statement. My condition is age greater than or equal to 25. If it is, it's going to print you're older than 25. Flow of control is going to drop all the way down here at the bottom. Okay, all the way at the bottom, even way past this print statement. It's going to drop. None of this else is going to execute if the value in the variable age is greater than 25. If the value in this variable age is less than 25, then the false portion of the statement is going to execute. That's an error, actually, syntax error. Okay. So if this value is actually less than 25, this else portion is going to execute, which means that's this block of code. Look, the if and the else are all indented the same. Well, this block of code actually contains another if statement. Is age greater than or equal to 13? We know it's less than 25, so now I'm testing whether or not it's greater than 13. If that's true, then this is going to execute, and it's going to bail out all the way at the bottom. If this is false, then this else portion is going to execute and then bail out at the bottom. So you look at this nested if statement right here and make sure you can follow along. You can put the if else inside of the truth block of this outer if statement, or you could keep it here in the else. I mean, well, actually you can't logically, but I'm just saying the if statement can be nested in any portion of another if statement. Okay, you can nest them. So with that, let's try a little exercise. This is going to be your exercise that you need to do, right? I'm on the right page. Yeah. So I just want a simple Python application that when you set a value of a variable to a numerical score, then your if statements are able to determine is that letter grade an A, B, C, D, or F. So if I give you a numerical score of 90, then your code will tell me I've earned an A. If I give you an 80 to an 89, your code will tell me it's a B. If I give you 70 to 79, it's a C, blah, blah, blah. So I want a Python application that can actually determine this. All right, moving on from that, now instead of nesting, there is another approach to handle the logic that you're trying to implement in code without nesting, and that is using Elif, E-L-I-F, E-L-I-F. Okay, so you have your normal if statement, okay, but instead of an else, what you have is Elif. And so that's saying this is the false portion of this resolution, or this, what this will resolve to, this condition. If this condition resolves to false, then this first Elif condition will be evaluated. So is age equal to 10? If that's false, which it is in this case, then it's going to evaluate is age equal to 11. That's false. It's going to fall to the next Elif. Age equal to 12. That's true. So that means that block of code is going to execute. Make sure you type this in and try this out so that you get a feel for what's going on. This last else portion, this last else block, is a catch-all, which means if all of these are false, then this last block of code is actually going to execute. Now, try it out. Change your previous challenge, which was to develop an application that when given a numerical score, you can determine if it's what the letter grade is. Well, do the same thing, but only use the Elif statements now instead of nesting your statements. So that's your second. Okay, so that's your second exercise. And then the last topic I wanted to go over was actually using the and or operators to combine our conditions. Okay, so in programming, when we join two conditions, so if we say some condition and another condition, it only evaluates the true if both the conditions are true. So in this case, this example right here, the variable age, this will only result in true if the age is greater than or equal to 25 and it's less than or equal to 35. So only the values 26 through 30, 25 through 35 will make this condition evaluate to true. So you see there's two conditions in this. This condition, condition 1, and this condition, condition 2, and they're joined with an and. That means both conditions have to evaluate to true for this entire condition to evaluate as true. And if that's the case, then the code, the block of code that is relative to this if statement will execute. I got a couple syntax errors in my slides here. Then you have the or operator, which means it will take condition 1, condition 2, and in this case, it will return true if one of them are true, or both of them are true, but only one of them has to be true for this whole condition to be evaluated, this expression to be evaluated as true. Given the and, both of them have to be true. With an or, only one of them have to be true. Okay? All right. Now, we got to remember when we get input from the user, when we use the input function, we talked about the input function in another module. So whenever we get input from the user, so when I say something like user input, so when I say user input equals input, enter your age. So whatever the user types in is stored in the variable user input. I got to remember that that is a string. Okay, it is not an integer. So if I say, let's just print it out, input, man, I'm typing horrible, user input. All right, so we're going to run this. Enter your age. I'll type 49, enter. Okay, my actual computer just froze up on me. Sorry about that. All right, so I got it to unfreeze and basically saying name error user input. I actually spelled my variable wrong. So, all right, so I want to print that. I'll save it. I will execute it, enter my age, 49, and then it's just going to print it out 49. Now, anyways, so when you look at this, you might think, wow, okay, so the number 49 is in the variable user input. That is not true. It is the string 49. Okay, so whatever the user types in from the keyboard and you get from the input function, it's a string. So you look here, if you say multiply that by 2, you would think that if I typed in 49, then it's going to output 98. But that's not the case. It should print 49 twice because it's doing string replication versus multiplication because it's a string. So if you want to convert that to an integer, then you've got to use the int function. So you could say something like this, converted age equals user input, oops, and I got to use the int function. So I got to use int is the function, my parentheses indicate that it's a function, and then I'm passing it what the variable user input, what the user actually typed in. So now if I say converted age times 2, then if I say 49, then it's not going to print 98. It's going to do the actual mathematical operator, the clean star multiplication. And vice versa. If you have an integer and you want to actually convert it to a string, then you've got to use the str function. So whenever you want to convert between numbers and strings, this is how you do it. You use the int in the string function. Now, it comes down to it's not necessarily when do you want to do it. Remember, you need to do it. So here's 2 examples. If you're getting input from the user, please enter your age, and they're going to actually give you an answer. and you're going to use that in a relational operator, and you're saying input age is greater than or equal to 20, you're going to get an error down here because input age is a string, what they typed in. So you have to convert that to an actual integer. So over here is the program that you get their input, and then you convert their input age by using the int function, and then you can use it in your Boolean logic conditions. Okay. All right, last assignment, last exercise or puzzle. So first of all, before you type this in, what does this program do right here? Look at it and write out what it's supposed to do. And then the last application, develop an application. It prints too many ninjas if the variable ninjas contains a value less than 50. And it prints it will be a struggle if the value is less than 30. And it prints I can fight those ninjas if the value is less than 10. Okay. So there's a third application for you to develop. All right. So that's learning module 5, basically adding a little bit of smarts to our applications. And you got 3 exercises to do.